So in this question, we're going to use logarithmic differentiation to find the derivative. So logarithmic differentiation is just really a tool that's going to make things nice. Like you can imagine, right? You can probably see the chain rule is going to happen in here. We've also got the quotient rule, and then you've got, x up in the exponent. It just looks like a mess, right? But using this new technique, it's actually going to make this quite a lot easier. So here's the process. So first, we want to take the natural log of both sides of the equation. And then we're going to use our log laws to just kind of rewrite it so we have individual terms. And then take the derivative of that is essentially how this works. So, all right, so natural log of, okay, so I've got the natural log of y, right, just taking the natural log of this side, is equal to, and then the natural log of the entire other side. So square root 150 minus 6x cubed over e to the power of 4x times cos squared x. All right, so now here's where the magic happens, right? Is now we know from log laws from previous lessons that we can rewrite that. So let's do that. This is the same thing as the natural log of y is equal to. So this would be the natural log of, and then just the numerator. So square root of 150 minus 6x cubed. And now really if it's in the denominator, then we're just going to subtract it. So then, but it's natural log of everything here, right? So we've still got natural log of e to the power of 4x. And then minus, because it's still down in the denominator, natural log of cos squared x. Okay, so from here, we'll just keep simplifying this. We've got the natural log of y is equal to. So we can think of this square root as really being to the power of a half. So what I'm going to do is I'm going to bring my 1/2 down front. So we've got 1/2 times the natural log of 150 minus 6x cubed minus, now bring the 4x, I'm going to bring that down front. So it's minus 4x times the natural log of e. Nice thing that happens there is that natural log of e is equal to 1, so that just cancels. And then minus, and if you remember, well, I'm sure you do, cos squared x, that's the same thing as just cos x squared. So I'm going to bring the 2 down. So 2 down. And then we've got, nope, not log, natural log of cos x. All right, that's looking pretty good. So now I know that doesn't look simpler, but now we can take the derivative of each of one of these pieces a lot easier. So we're going to use implicit differentiation. All right, so let's take the derivative. So we've got, this would become 1 over y times y prime. Right, just implicit differentiation there, just with the y term, is equal to, and then you have 1 over 2 times, and then the derivative of natural log is going to be 1 over the argument. So 150 minus 6x cubed, okay? And then times the derivative of the inside. So in this case, that would be, so bring the 3 down. We've got negative 18x squared. Okay, and then moving on here. So now we've got just this would be just become minus 4. And then moving on to this one, we've got minus 2 times 1 over cos x, and then times the derivative of the inside. So that would be times negative sine x. All right, so now let's just clean this up. So instead of having it written this way, let's write it as y prime over y for now is equal to. So I see here I've got negative 18 over 2. Let's just call that negative 9. And then x squared over 150 minus 6x cubed. Okay. And then minus 4. And then since I have minus negative sign, we're going to call that plus. So plus 2. And then sine x over cos x, let's just call that tan x right now. All right. So from there, what we'd like to do is actually write this a little bit different. I'd like it to all be over the common denominator. So I'd like this to be, over 150 minus 6x cubed. Same with this one, minus 6x cubed, right? But then I'd have to multiply the top, or the numerator of each of these as well. So that's 150 minus 6x cubed. And then same with this one. Okay, so let's write that. So y prime over y is equal to, so far I know for sure my denominator is that, and I have negative 9x squared, and then this would become negative 600, and then plus 24 x cubed, and then distributing this guy in, so now we've got, so 2 times 150 would be 300 tan x. And then distributing the last part in, we've got negative 12. And you've still got x cubed tan x. All right, so now we can simplify things a bit more, but and we probably should have maybe the numerator with descending power of x, right? Like this is actually like our highest power, starting with this one and then working our way down. But this is pretty good. For simplicity, let's just leave it there. Okay, so now the next thing we want to do is we have this like random y in there, right? So what do we do with that? So what we're going to do, I'm going to just bring this up to the other side. So now we have an expression y prime is equal to, and now we've got y times all of this stuff, right? But what is that y? So maybe don't write it in there yet, but what is that y? Well, we know what y is. We have an expression. Y is equal to all of that. So we can just actually plug that in now. It's going to turn quite messy, but that's it. So instead of a y, we're going to write down what we know y is equal to. So that is 150 minus 6x cubed over e to the 4x times cos squared x. All right, so that was y. So now we're just going to multiply that by everything else on this side. So that's multiplied by negative 9x squared minus 600 plus 24 x cubed plus 300 tan x minus 12 x cubed tan x all over 150 minus 6x cubed. All right, so there you go. That's our derivative. It's not the prettiest derivative, but it is the derivative. One thing we could do, I guess, too, we could have simplified this. I won't make you do that, but you can see actually 3 goes into everything here. I could factor out a 3 in the numerator, factor out a 3 in the denominator, and simplify it a bit, but to tell you the truth, this is pretty good at this point.